Hello and welcome to another video using PoseNet and ml5.js. But in this video, what I'm going to do is take the output of the PoseNet pre-trained model and feed that into an ml5 neural network to train a pose classifier to recognize when I'm making certain motions like a Y, an M, a C, and a A. Before I begin coding, let me quickly mention something I added between the last video and now. I'm mirroring the image so that when I raise my left hand, it's mirrored to me what I'm seeing on the screen in front of me over there. This is important for interactivity. It makes it feel much more intuitive and natural to see yourself mirrored. You might recall that the ML5 has a specific function called flip image that will do it for you, but I actually found, because I'm drawing all this other stuff, that it's easier for me to just write the code for itself, which involves a translate and a scale. In other words, typically if I'm drawing an image at 0, 0, I'm drawing it right here, and the image gets painted across the canvas. But if I call scale -1, 1, it sets the x-axis going in the other direction. So positive pixels go this way. And if I translate over to here and put 0, 0 here and draw the image this way, it will appear reversed, inverted, flipped to the viewer. So that's what's happening in these 3 steps right here. The 2 videos that I'm assuming are prerequisites here are the previous one where I covered all of the code for this particular PoseNet example that you're seeing running right here in the web editor, as well as this train your own neural network set of videos that covered the basics of how the ml5 neural network function works to train a model to play musical notes based on where the user clicks their mouse in a canvas. To get started, I could really begin with either one of these sketches. For example, I could go and get my PoseNet code and bring it into this particular sketch, or I could take the neural network code from this sketch and bring it into the PoseNet one. I think I want to continue working from the PoseNet sketch itself. And the first thing that I want to do is create an object to store the neural network. So I'm going to call that brain. And then after I initialize the PoseNet model, I'll say brain is a new ml5 neural network. And you might recall that anytime you create a neural network, you can specify a set of options for how you configure that neural network. All of the options for how to configure an ml5 neural network you can find on the documentation page for the reference. I'm just starting with these 4 basic properties: input, outputs, task, and debug. So let's come over here to the whiteboard and let's diagram out what's going on. Now remember, we're starting with the PoseNet machine learning model. We're sending an image into that model as the input. The PoseNet model then takes that image and does pose estimation, making a guess as to where all the key points are on the human body that it sees. And all of those points come in the form of XY pairs, coordinates. Here's my elbow, here's my shoulder, here's my ear. It doesn't have an ear, whatever. Nose, there's 17 of them. All of this data is what I want to send in as the input to my ml5 neural network. ml5 neural network will take all these XY pairs and classify them into a given pose that has a label. It's a dab pose or a Saturday Night Fever pose. I don't know what kind of poses I'm going to make. I'll do YMCA. Why not? This now tells me how I want to configure my neural network. I want to send it 17 pairs of numbers. That's 34 inputs, and I wanted to classify those 34 numbers into one of 4 labels. That is 4 outputs. 34 inputs, 4 outputs. The task is classification, and I do want to see debugging as I'm training the model. And I have to give those options to the ml5 neural network itself. This is where things get kind of complicated because I need to call brain.addData. That's the way I add training data to my neural network. So somehow I have to have some kind of interaction. Maybe I press a key, I'll press the key Y, and then it'll wait a little bit and it'll know after 5 seconds for when I come over here to start collecting pose data for a certain amount of time, then it will stop, and then I'll come back over here and press a button and do something else. So this requires a lot of thoughtfulness in terms of how I might build the interaction around this. I'm just going to try to do it in a simple way that I can get it to work right here, right now in this room. For a much nicer example around interaction and collecting pose data, you can take a look at Google Creative Lab's Teachable machine. So I've made video tutorials about training image models and sound models that can actually be imported into ML5. At this moment, you cannot import the pose model into ML5. Well, that's something that we're working on, and I'm hoping that this video tutorial will lead the way to that. But essentially what I'm building is a pose teachable machine. I just won't do as thoughtful of an interaction as here in the actual Teachable Machine project. You can see here in Teachable Machine, for example, there's a button that I can press, and it's going to give me a 10-second countdown. And then when I come over here, after 10 seconds, it's going to start collecting my poses. So this is a much nicer example. I encourage you to look at it for inspiration. Of course, that was terrible training data, but now I'm going to go back to my code and try to implement my own version of this. To keep track of the flow of the sketch, let me add a variable called state, and I'll just initialize it to waiting. And then I will add the keyPressed function. And when I press a key, I want to say state equals collecting. Only I don't want to start collecting immediately. I want to wait a little bit because it's going to take me some time to walk over there and get into my pose. So I'll use setTimeout for a delay. SetTimeout is a built-in function in JavaScript. It's not part of P5 that will execute a function after a certain amount of time. And maybe I want to execute this function after a certain amount of milliseconds. So I can put a little function inside here. I could use the arrow syntax. There's a variety of ways I could approach this. Let's just say 10 seconds later. Right, so when I press the key, 10 seconds later, set the state equal to collecting. Also have a variable called target label. And I'll set the target label equal to the key that was pressed. All right, so I have this function going. When I press the key, whatever key I pressed is the target label. I want to see that in the console. And then 10 seconds later, I want to see it say that it's starting to collect. Let me make that 1 second later so I don't have to wait as long. All right, and I'm going to press the Y key. Y, collecting. Perfect. So this is the right idea. Once that state switches to collecting, I want to call the ml5 neural network addData function. Where I want to call the addData function is right here when I have a pose. So when I have a pose, I want to say brain addData, and then the inputs and the targets. The inputs are all of the XY locations of the pose itself. There's 34 of them. I mean, I have kind of an issue where the camera can't see my legs, so I probably should ignore some of them, but I'm just not going to worry about that. I could also consider using the confidence scores. Like maybe the confidence score, the neural network could learn when it's a low confidence score to kind of ignore that point. But I'll ask you to try all that stuff if you're making your own version of this. I'm just going to use these 17 XY pairs. So I need them to be in a plain old array. And if you recall, they're not in a plain old array. They're in this pose.keyPoints, which each has an object, which is position.x. So I need to flatten the data. Whatever format the data is in, I want to just put it into a plain array. So I'm going to grab this loop. I'm going to create an empty array called inputs. And I'll just say inputs.push x, inputs.push y. So this is me going through the entire pose, getting all the XYs, putting them in an array, which is the input to the neural network. And what's the target? It also wants an array, but in this case it's one thing, just the label. So I can take the target label, put it in an array, and that's what I'm giving an addData function. You might recall in my previous neural network examples, I was making objects that I passed in with named inputs and outputs. So this is just showing you that you can do it either way. If I want to have names for all the inputs and outputs, I can build an object with properties. If I just want a big array of numbers, I can just make it a plain array. But there's a new problem. The new problem is, once I start collecting the data, I'm going to strike the pose, and maybe I'll collect like the pose for a little while. I got to stop collecting the pose. So let's go back up to where I started collecting the pose. I'm going to do something awful. This is so painful. I don't want to do it. Let's just do it, and then we'll revisit it later. We will. I'm going to call setTimeout again right inside here because a second later or 10 seconds later, I want to stop collecting. This might be some of the worst code I've ever written. It's really awful to look at. It's what's informally known as callback hell, and there's a variety of ways I could approach this differently by using promises and async and await. But in this case, really all I want to do is set the state to collecting in 10 seconds, then 10 seconds later, set it back to waiting, and I think this will work for me. Let's give it a try. I need to first press Y. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. Collecting. 10 seconds later, it should say, not collecting. All right. Okay, that worked. What I'm doing here, quite poorly I might add, is implementing a state machine. So it might be nice for me to, in a separate video, which if I can ever get around to making it, talk about a more sort of proper way of implementing a state machine, but this works. I set this state variable to collecting, 10 seconds later, set it back to not collecting, and during that time, I am adding data to the ml5 neural network. Sorry for a second. I'm coming to you from almost several weeks, a month later, a really long time. Look how much my beard has grown, to issue a correction. I have made a very significant error in this video that you're watching, and I don't correct it any time throughout the course of this video. And the error is that I forgot to actually include an if statement here in the got_poses event. When I receive a pose, I should only actually call addData when the state is collecting. I was just doing it anyway. Sure, I set the state to collecting and waiting and then to collecting and waiting, but I didn't actually include a conditional. So I had a lot of messy extra noise in the data. So I just redid it now in the time that I'm talking to you right now and collected the data again, retrained the model, and performed so much better than it actually does in the video. And the code that's released has that small correction in it. Amazingly, it kind of worked anyway, as you'll see as you continue watching, but just note that correction when you go look at the code. It's an important detail. Thanks, and enjoy the rest of this video. Immediately what I want to do right now is add a function to save the data, because I do not want to do this many times. So in key pressed, I'm going to say if the key is S, brain save data. So let me quickly try collecting that one pose again and make sure it can save to a JSON file that I can reload later. Press Y. Got 10 seconds now. Collecting. Not collecting. So I can come back over here. I can press S. And I now have a JSON file that was saved. Let's take a look at that file. And this is what that file looks like. For every single pose, it's got X's. Those are the inputs. There should be 34 of them. 0 through 33, and then it's got the Y's, which is one label Y. So these are all of my poses saved here in this big JSON file. Great, I can now train them, I can now collect the data for all 4 of those poses. Let's see if I can manage to do that. First, Y. Collecting. Not collecting, okay. Now I'm gonna do M. Collecting. Not collecting. Okay. Should I really do all of these? C. Really noisy data. C. One more. A. Okay. All right. Now let me save the data. Save. Phew. Okay. Stop. Stop the sketch. I've got the data. 2 megabytes. So that was a lot. It's a large file, but not ridiculous. I'm going to rename it to YMCA. I'm going to now upload it to my sketch. And then I'm going to comment out all of the data collection stuff, because I'm just going to consider myself done with data collection. And I'll actually duplicate the sketch, and let me call this one data collection. I'll duplicate it and call this one now model training. The next step is when the sketch runs to load the existing data. So now I don't need to collect the data. I could load the data, collect more data. There's so many ways you could do this, but I just want to load what I collected previously, and then when the data is ready, when it's loaded, then I can call the train function. There's a lot of options I could configure train with, but I just wanted to go for 10 epochs. That's running through all of the data 10 times. I might need a lot more. When it is finished, I want to just console log that it's been trained and save the model to my downloads folder so that I have it saved. Let's see if this works. So I see the graph pop up that would show me the loss while it's training, but it never went down at all. Let's try giving it 100 epochs. This is not a good sign. Guess what I forgot to do? Something very important. What is the data that I'm collecting? These XY values are on my P5 canvas, which has a resolution of 640 by 480. So they're large values. They need to be normalized down to a standard between 0 and 1. So I'm going to let the ml5 library take care of that for me by just adding the normalize data function. So right here in data ready, before I train the model, I can call normalize data. Let's run it one more time. Let's just go down to 50 epochs. And there we go. Now I see a loss going down the way I had hoped it would. And the model is trained and presumably saved to my downloads folder. Let's go take a look. Because I was doing this multiple times, I have a mess of files down here in the downloads folder, but the one that was most recent is number 5. So I'm going to get rid of everything and just rename these back to the default names. And now I can upload the model that I trained back to the P5 web editor. Let's duplicate the sketch one more time. I'm going to call this PoseNet deploy. Let's create a folder, call it model. Add the model files. I can see the files over here. And now, instead of loading the data, I can load the trained model. But if you recall from the previous videos, there are 3 files for the model, so I need to create an object to store all 3 file names. The format for how that has to be, I can find on the reference page for ml5 neural network. Copy this to clipboard, bring it over here, and put in my path, which is just called model. Let's run the sketch and see if I can just get model ready here in the console. Oh, I'm just missing a quote. Thank goodness. And I'm inconsistently using single and double quotes. Let's fix that. Oh, it's not neural network. I called it brain. So close. PoseNet ready. PoseNet ready. Huh? Oh! I have a callback for PoseNet for when it's ready called model loaded. So this needs to be, I'll call this brain loaded. So remember, we're using 2 machine learning models here. PoseNet, which is doing the pose estimation, then the outputs of that model are going into my own neural network that I've trained called brain. Let's try this one more time. Pose classification ready, PoseNet ready. Wonderful. Incidentally, the classification model was loaded first because PoseNet actually has to reach out to the cloud and download the model from Google servers. We are so close to being done with this, just a couple more steps. Once my brain is loaded, I can actually ask it to classify. So I can say brain.classify inputs, and when you've got a result, call got_result. The question is, what are those inputs? These are those inputs. The same thing I did when I was collecting the training data, grabbing the XY pairs, flattening them into an array. I need to do that for the inputs that I'm sending in when I'm deploying the model and asking it to guess, asking it to do that classification. Here's the loop from the data collection where I flattened it into a single array. I can grab that, and I can bring that in here. But I'm going to, once I get the result, want to do this again. So really, I should take all of this, write a new function called classify pose, make sure there is a pose in the first place. Then once the brain is loaded, just call classify pose. I need the got result callback, which has 2 arguments, error, results. And I'm just going to say console log results index 0.label. Let's console log the whole results as well. So in theory, the first pose I get should be if there's a pose when the brain is loaded, or there won't be. So I'm going to have to, I'm going to put the recursive loop call in here and call classify pose again. So the idea is when the brain is loaded, classify a pose. If there's a pose, call brain.classify. But what if there's no pose? I'll never go get a result. Otherwise, this is really silly, but I'm anticipating an issue that I'm going to have. So what I'm going to do is, if it doesn't detect a pose, let's just say, hey, in a little bit, why don't you wait like 100 milliseconds and call classify pose again. So that way it'll continue to check. So at some point, eventually, there will be a pose. It'll call brain.classify. When that's done, it'll call it again. If there ever loses detecting a pose, it won't stop. It will actually continue and just every 100 milliseconds keep trying again. All right, I think there's no way this is going to work, right? Let's give it a try. All right, pose ready. Y. A, Y, C, A, Y, M. What? This actually worked. Well, let's just throw caution to the wind and draw the label in big letters on the canvas. I'm going to set it equal to Y so that I see it right there at the beginning. And at the end of draw, I'm going to say fill 255, 0, 255, no stroke. Okay, there's the Y. Oh, it's going to be reversed. It's going to be flipped because of the, so I'm going to also put push here. It doesn't matter, Y is symmetrical, Y and the C won't work. And then pop here so that the Y is always in the center. Okay, now when I get a result, set it equal to that label. I kind of want to see the confidence. So I'll log the confidence to the console because I want to see how sure it is about that particular label. All right, here we go. One, two, three, four. It's fun to stay at the YMCA. It's fun to stay at the YMCA. We need these to be capital letters. One, two, three, four, five. Let's go slower. Y, M, C, A. So thanks for watching this. I'm kind of shocked it works. There's so much more that could be done with this. First of all, a question came up, which is, you forgot to normalize the data after during this classification process. And ML5, one of the nice things it does is it saves the normalization minimums and maximums from the training process and then reapplies them later. So I don't have to call normalized data again. That's happening behind the scenes. Otherwise, what other kinds of labels, what kinds of other outputs, could I play different drum beats based on a pose? What other kinds of things could you classify? If I collected a much larger data set, if I was more thoughtful about how I was collecting the data, could I get this to be much more accurate? Give this a try, make something. What I definitely also want to do, which I'll need to make another video about, is turn this into a regression. So could I take that example where I play a frequency, and alter that frequency by changing my motion, my movements? And in fact, I could actually have the output of that regression be color. That might be something to explore. I got this idea from a viewer named Darshan who submitted a community contribution where instead of painting with sound, you're painting with color with a regression. And that's really interesting because it requires you to have 3 different outputs, an R, a G, and a B. So take a look at that project, and maybe I'll think about doing something with poses and color output in the next video tutorial. I have an idea. What if I only update the label if the confidence is above a given threshold? Let's take 75%. Maybe this will eliminate some of the noise. It totally helps, right? Because it's not flickering as much because it's only altering it if it's really confident about what the pose is. And I can maybe make that threshold even higher. The M and the A are so similar. You're all right about that. It is able to get it though. M is something slightly different. I'm a little out of breath, but one more thing I want to say. Again, unlike with my previous examples where I've trained models that do something similar based off of images and pixels, in this case, the pose data is more generic, that I think if you go to the URL for this sketch, which is in this video's description, you could make those poses and hopefully it'll recognize them. So give that a try, and I can't wait to see you in a future coding video. Goodbye, have a great day.